Solving quadratic equations by completing the square. Our goal in order to solve quadratic equations is to get the x all by itself. In order to do that, we need to get a perfect square on one side of the equal sign and then take the square root of both sides. Here's an easy example. I have 4x squared plus 11 equals 59. Now there's no middle term, there's no b term or x. So I'm just simply going to move the 11 to the other side. That gives me 4x squared equals 48. Now I'm going to divide both sides by 4 in order to get the x squared all by itself. Now I have a perfect square on one side. X squared is a perfect square. The other side is not a perfect square, but that's okay because we know how to simplify. Now take the square root of both sides, and that gives you x is equal to the square root of 12. Now you should know how to simplify that. X is equal to, because I'm taking the square root, I get a positive and negative version. The square root of 12 breaks into 4 times 3 and 2 times 2. I have a pair of 2's that comes out, so that gives you x is equal to a positive 2 square root of 3 and a negative 2 square root of 3. Here's another example. We want a perfect square on one side. Well, look at the left-hand side. If you're good at factoring, you'll see that this can break up into x plus 6 times x plus 6. Well, x plus 6 and x plus 6 come together as x plus 6 squared. So I do have a perfect square on the left-hand side. By factoring it, I got x plus 6 squared. That's still equal to 28. So we've reached our goal of getting a perfect square on one side. Now we can square root both sides, which is going to break up into positive and negative versions. That's going to give me x plus 6 is equal to the square root of 28, and x plus 6 is equal to negative square root of 28. Before we go on further, let's see what the square root of 28 is. Square root of 28 breaks into 4 times 7 and then a pair of 2's. The pair of 2's will come out, so that gives me 2 square root of 7, which leaves me with x plus 6 is equal to 2 square root of 7, and x plus 6 is equal to negative 2 square root of 7. On both of these, we're going to subtract the 6 to the other side. And when I simplify these, I get x is equal to. Now, the square root of 7 and the 6, they're not like terms, so we can't combine them. We leave them separated. Negative 6 plus 2 square root of 7 and x is equal to negative 6 minus 2 square root of 7. Those are your two answers. Now the question lies, what happens if they didn't give me a perfect square on one side? Simple, we create our own. So if they don't give us that perfect square, we make our own. This is called completing the square. We're completing a perfect square. Here are the steps. I would make sure you have these written down off to the side. First, we only want the a and the b terms on the left-hand side. So ax squared plus bx on the left-hand side of your equation. Everything else on the right. We have to make sure that a term is 1. If the a term isn't 1, we don't want to use completing the square. If we can simply make the a term 1, awesome. If we can't, use another way of solving quadratics. We always will divide that b term in half and then square it. Go through the rest of it later. Step number 1. We need the ax squared and the bx on the same side. That means I'm going to have to move my 12x to the left. Step 1 is complete. Now, step 2. The a term must be 1. Well, our a term is 1, so we're good. Step 3, divide the b term by 2, and then that creates a new c term. So what does that mean? You take that middle term, negative 12, divide it by 2, and square it. That gives you negative 6 squared, and negative 6 squared is 36. So this right here is going to be our new c term. So we add it to both sides. Plus 36. Well, whatever I do to one side of the equation, I have to do it to the other. And that's why we do it to the right-hand side also. Yes, we're adding 36, but since we're doing it to both sides, it's not actually changing the equation. That gives us, now, create a new factor. If you want to, you could say, well, that's going to come out to x minus 6 times x minus 6, and that's going to give us x minus 6 squared. That's the long way of doing it. Here's a quick shortcut for these things. Simply write the square x, and then take your b minus 2 right there. See that negative 6? Whatever is in there, your b minus or b over 2, that's always going to be this middle term. So kids always say, I don't know how to factor it. You don't need to know how to factor it. You're simply stealing that middle term and putting it there. And the right hand side didn't change. We can take the square root of both sides. When you do, you get a positive version and a negative version. Now we just need to solve for x twice, one for the left and one for the right. We do that by adding 6 to both sides, and you'll do that for both equations. Gives you x is equal to 10 and x is equal to 2. Here's another one. Now, step 1, ax squared and bx need to be on the left-hand side. They are on the left-hand side. They're just not written in order. So we're going to start by rewriting them in order. 3x squared plus 18x is equal to 45. Now, step 1, done. Step 2, the a term must be 1. My a term isn't 1. So what I'm going to do is take that 3 out. Divide everything by 3. And I can do this because whatever I do to the left-hand side, I can do to the right-hand side. That gives me x squared plus 6x is equal to 15. I'm going to take that middle term, divide it by 2, and square it. So what that's going to be is this term right here, that 6, I'm going to divide it by 2 and square it. When I square it, I get 9. So now I'm going to add this 9 right here to both sides. Plus 9, plus 9. I need to factor, and since the left-hand side will always be the same, it's really simple. X plus that middle term to the little 3 right there is always going to go right here. Now I can take the square root of both sides. As a little side problem, the square root of 24 breaks up into 8 and 3. 8 breaks up into 4 times 2, and 4 breaks up into a pair of 2's. That gives me 2 on the outside, but 3 times 2 is left over on the inside. So that gives me a 6 right there. So this is going to break into 2 separate equations. The negative 2 square root of 6 and the positive 2 square root of 6. Now I simply solve them. I'm going to do that by subtracting 3 to both sides for both equations. Gives me x is equal to negative 3 plus 2 square root of 6, and x is equal to negative 3 minus 2 square root of 6. Now, make sure when you're answering these questions you read the directions. If you're typing this into a computer, you may see that they want a plus minus symbol, and most of the time though, if you're typing this into the computer, you're going to see that they want 2 separate equations. So if you're writing it one way but keep getting it wrong, make sure you're checking the directions for your computer program to see which way they want it written. Okay. It may not look like it, but this is actually a much more difficult problem than the last one, and you'll see why in a second. Step number 1. I need the ax squared and the bx on the left-hand side, nothing else. So that means I need to move the 5 to the right. So far, so good. Step number 2, the a term must be 1. It is. Step number 3, take that middle term divided by 2 and square. Well, we've done that multiple times, so that gives me 3 over 2 squared is equal to, well, it doesn't reduce. So in the last few problems, I've been left with a whole number. Here, I'm not. I'm left with 9/4, and this is why this problem is a little more difficult. So now we're going to take that 9/4, and that's our c prime, our new c, and add it to both sides. Well, if you don't remember how to add fractions, here's a crash course. I have 9 over 4 plus 5 over 1. I need a common denominator. So I multiply the bottom by 4. Whatever I do to the bottom, I do to the top. That gives me 9/4 plus 20/4. Well, 9 plus 20 is equal to 29 over 4. So on the right-hand side, I get 29 over 4. Now, usually the part where everyone gives up, they say, I have to make that into a square. That's true, but it's not difficult because you already know what number to use when you factor. That 3/2 is always going to be the number in here. So your b over 2 is always the number that goes in there, so it's never difficult. X plus 3 over 2, and that's still equal to 29/4. Now, just like always, take the square root, which gives you a positive and a negative version. I can take the square root of 4, so I do. Now, in order to get x all by itself, I need to subtract 3/2 to both sides. I do that on both of them. Now, if you notice, these are separate fractions, but they do have a common denominator. So sometimes your books will want them written like this, and sometimes your books will want you to take it one step farther. Because they have a common denominator, I can write them as a common denominator. So please realize some books are okay with the first version, but most books right now are wanting the second version over the common denominator. All right, now that we've already finished all of the hard ones, there's a couple other questions that are going to come in that are supposed to be easier, but a lot of times confuse kids. So let's take a look. They want you to complete the square. And in my mind, that means solve for m. But that's not what they're asking here. What they're asking for is that missing term right there so that this can become a perfect square that we can factor. So do the same thing. This would be your b term. So remember, we need b over 2 squared. So for this problem, it's going to be negative 10 over 2 squared, which gives you negative 5 squared, which is equal to 25. So this would be plus 25. And then in the parentheses, just like always, you're going to take that term inside of the parentheses here, the negative 5. So you would get x minus 5. So your first answer would be the plus 25, and your second answer would be the x minus 5. And just for practice, they give you another one that's asking the same thing. Fill in the blank here. So you say 21 over 2 squared, and that was going to give you 441 over 4. So you would write 441 over 4. And then they want you to factor it. So you would put the square, you put an x, and the factor is always the same number. It's always going to be the number inside the parentheses there. So you write plus 21 halves. And those are your two answers.